So my name's Jeffrey. So a little bit about me. I'm a creative technologies major with a computer science and web development minors. I've worked as a PC deploy technician with BITS for the past 4 years. My job's basically replacing teachers' computers, swapping over their data. And through this, I've earned a lot of different certifications. I've always been, so how did I end up in creative technologies? I've always been a hands-on person, and I've always loved technology. In high school, I took the engineering and mechatronics pathways, and I was on the robotics team for 4 years. And I did FIRST Robotics, Vex Robotics, and Skills USA. And through Skills USA, I competed in humanoid robotics, additive manufacturing, and urban search and rescue robotics. And I also have a bearded dragon named Norbert. So my theme is using CAD and CAM to bring objects into and out of virtual spaces. So through this next couple of projects, I'm going to walk you guys through different ways that I've modeled things and different ways I've produced them using different CNC machines, as well as my design methods and challenges that I faced along the way. So my first project is Norberts Treadmill. This was my intermediate project for 101. My problem space was Norbert didn't get much exercise when I wasn't at home. My parents were always busy. They didn't have time to take him out of his terrarium, let him run around. So I wanted some way for him to get exercise. For this project, I used Fusion 360, which was a little odd because this was 101 and Zane taught us Tinkercad. But in high school, I used Autodesk Inventor, which is pretty similar to Fusion. And asking around the lab, people seem to use Fusion. So I decided to kind of bite the bullet and give Fusion a try. This gave me a lot more precision over the design than Tinkercad would have. As you can see, I've filleted the edges. This is so, since I'm working with an animal, obviously I need a smooth surface. It also made the pieces stronger, give it more support. I have more control over the hole placement for the wooden dowels and the size of those. I used wooden dowels for this because if I used ball bearings, it would be too slick for him and he would kind of just roll off of it. He wouldn't be able to really use it. So using wooden dowels and the friction with the plastic made it decent enough that he could kind of pull on it and do well. The fabric I used was a t-shirt. This was through a lot of trial and error. The fabric couldn't be something like felt or canvas where his claws would either get stuck in it and not be able to come out or not even be able to get into it. But as you saw in the picture before, he likes to sit on my shoulder, and I found that way that t-shirts is the perfect material that he can dig into but not get stuck in. So the next project is a Nintendo Switch model. This was my final for Chris's Fusion class. I feel like this really shows the first half of my theme well, of being able to bring a real world object into a virtual space. This took a lot of long hours to do. It was a very meticulous and tedious process of using calipers and rulers to kind of measure every little object, make sure that they were all fitting the right way. I also overlaid images from my phone over it to kind of double check that everything is going in the right space that was needed. Because sure, I can tell that the button is this wide and they're this far apart, but having a picture to overlay onto it to kind of double check where I'm at was really helpful. And for some of the more complicated images, like the logo on the GameCube controller right there, or on the game cartridge, I took an SVG file. I put an image into Inkscape, traced the bitmap for it, got the SVG, and then threw that into Fusion. The hardest part for this project was definitely the GameCube controller. I used the form mode in Fusion, which is something I wasn't very familiar with, and it really threw me off. You're kind of given what I'd consider like a block of clay with like a grid over it, and you kind of have to push and pull these different points to work with it. And it was something I wasn't really familiar with, but it was the best way to get an ergonomic look and smooth surface for it. My next project is the Campfire Stool. We all know the Campfire Stool. You have to make a stool out of one sheet of MDF. The only real constraint is each piece has to fit in a 12 by 12 inch square. So this gave me a lot of design choice and freedom for this project. When I hear campfire, I think of the times I spent in Boy Scouts. Many of you may not know this, but I'm an Eagle Scout. So I wanted to kind of implement that into this project. So I chose the basic Boy Scout logo, which is just a fleur-de-lis. I thought it would look very simple and minimalistic, but still nice, extruded through everything. For some other design choices, I wanted a good seat, obviously, and I wanted a little angle on the back so that I could kind of rock back and forth in it, because I tend to be very fidgety, so I thought that would be very nice. And this took a lot of different iterations. I would draw something up, cut it out on the laser cutter on a piece of foam core, see if the angle worked well, if the seat was nice, that kind of stuff. Go back into Fusion, tweak it again, go back, cut out another one. Once I found one I liked, I made a toolpath in Fusion for the crawlbot, and then cut everything out and assembled it. This next project is foot traffic. This was my final for intermediate. Inconvenient sidewalks are all over campus. The main one I can think of is this curvy one by the cage. Most people aren't going to walk through it. They're going to just skip straight through the grass. And this can be very bad for the lawns. It makes it look very bad. They can create dead spots, ruts, can even create places where it waterlogs and gets puddles. So we decided to make a project to kind of track when and how many people cross the grass, and then display that on a website to show that it's a problem. The components that we used were a microwave sensor. We did this because we saw most outdoor security cameras use microwave sensors to track motion, and that's really what we were going for. So we have that and a little RTC clock to track the time, and an SD card to write to store the data, since we didn't have Wi-Fi out in the field, and then an LED to show that we've successfully wrote down the data. My job for this project was really the design of the housing and the models. So since we didn't have the actual circuit board with us when I was designing the housing, we only had the easy EDA sketch. I kind of had to insert the image, the sketch into Fusion, kind of trace that. But that gave me exactly where to place the components, where to place the mounting holes, etc. And then for the components, it was the same thing as the switch, using calipers and rulers to kind of measure everything out. For the housing, we decided to make it a circle because the microwave sensor can see in 360. And so by making it a circle, we could easily make that window the field of view that we wanted the sensor to see out of. So luckily for us, it was 180. And then the height of the window was kind of decided based off the height of all the components inside, so we could still see in, but they could still see out. We needed a place to store the battery, so we made a little bottom component, kind of like a dish, kind of to store the battery. So the whole diameter of the housing is based off of the battery bank that we had, with a little wire to route the cable down into the battery. And then since it was outside, we kind of needed to be weatherproof. So I made a little rain cone to kind of go on top to help deflect the rain. So then my final project was my capstone, which is a rapidly deployable table. My problem space for this was I've noticed that there's a lot of unused tables in the lab. And I was thinking back to vehicles where we were doing the auto cart and the Autobot track in here. All the tables were pushed to the side, and it made this whole quarter of the lab kind of unusable. So I wanted to make something that could be easily set up and taken down to kind of eliminate all of that extra space that's not being used. This was a very back and forth thing with Fusion. I would model something in person, go to Fusion, and model that in person, and kind of go back and forth. It started as a little paper prototype, and then I was like, okay, it works in paper. How would it work with actual objects? So then I went into Fusion and modeled it and figured out all these little spaces where things had to fold and things. Then once I modeled the paper thing, since I used parameters, I could kind of expand that into foam core model. So I expanded the model to 2 feet. So I then had all the dimensions to make it out of foam core. Just to kind of reaffirm that it would work with solid objects that weren't paper. So then the next thing was, how do I make wood fold? That was kind of the hard part. There's a lot of research with different hinges, and I landed on these, which are called barrel hinges. They're flush 180-degree hinges. So to get a better understanding of the hinge, I modeled it in Fusion just to kind of understand how the joints work and how it fits and everything. Then I had to figure out how to make wood lighter, because if I used solid wood, it would be extremely heavy. So I decided to make it kind of like a wall in a sense, where you had a front and back face and then these ribs or studs between it to kind of give it some structure and support. And then I ran a bunch of Fusion stress tests to figure out what was the right number of studs that I would need to make it as light as I can. As you can see, one stud for this one's clearly not good enough because it completely bent in. And then with another test, you could see exactly where all the stress points are. So for this one, I may want to add like a vertical beam going through it to add some support. After that, I made a wooden model to kind of verify that the hinges would work as I wanted them to. This was one of those moments where it was like, it works in theory, there's no way it's going to work in practice. And then you finally get it to work and it folds and moves, and it's like this giant eureka moment. You're kind of on cloud nine that it works. The problem with that was it's hard to drill the hinges. They need to be very exact, otherwise it creates too much pressure for them. And it's impossible to do that by hand. I think they needed to be 10.6 millimeters exactly to be like flush. So I made this little hole guide where the center of the hole for the hinge is exactly 10.6 millimeters from the edge. Then you kind of just mark the inside of the face, slide the hinge on, mark it, and then you're good to go. After that, it was just modeling everything. I made one final model with all of the ribs and studs that I wanted. I found some handles and was like, it's gonna be heavy, so I need handles on it to make it work. So then I did some user testing and figured out handle placement. I put two on the front so you could kind of grip it and pull on it, as you saw in the first video, the little GIF. And then I put one on the other side so you could carry it, and then one on top so you can kind of have some kind of leverage to lift it up. So what's next? I'm going to be moving to Maryland. Last semester for Zane's intro to capstone, we had to find job posts and for jobs that we could apply for. And I was like, if I can't apply for them, why don't I apply for them? So I threw my name in a bunch of different hats and somehow landed this one. I'll be a product developer for Vorbeck Materials, where they create communication devices for first responders in the military. These are different kind of vests and harnesses that can transmit video feed and audio from like 30 feet below the surface type stuff for when natural disasters come. My job will be looking at customer feedback, finding common problems, figuring out solutions and innovations for them, and then making a rapid prototypes to show that we can solve them. Here's how, and then handing that over to the engineering department. They use the same 3D printers and laser cutters that we have, which is an easy fix, like an easy swap. The only thing that's different is they use SolidWorks instead of Fusion. But from what I've looked at, it shouldn't be too much of a change, since it's probably going to be like going from C+ to Java. It'll be pretty similar. And that's it. Thank you.